So this is the first problem of today's Codechef Div 2. And in this problem, we are given that we have a binary string s of length n, and we can perform the following two operations on it. Choose an index I and flip every character of s from index I to n. So flipping a character basically means if it's a 0, convert it to 1, and if it's a 1, make it 0. So this is just the example. I'll explain this in the writing part. So then we have to find the minimum number of operations required to turn S into a alternating string. S is said to be alternating string if Si is not equals to Si minus 1. That is, the two consecutive characters for no two consecutive characters are same. So let me explain this. So we have a string like, second. Yep. So we have a string like something like 0, 1, 0, 0, 1, 1, 1, 0. So, and finally, we want something like either 0, 1, 0, 1, 0, 1, 0, 1, 0, or maybe something like 1, 0, 1, 0, 1, 0, 1, 0, 1. Now note that both of these are correct ways to transform this string. Like you just like this is not the only correct way. We can have like this also. So out of both of these, we need to find what is the minimum number of moves required to turn this string to either this one or this one. Now, what is the number of, like, how the moves are being performed? If we select this, then every character from here to here will get flipped. But so one way is, first let's try to make this string. And when we're trying to make this string, this character is okay, this character is okay, this character is okay, this character is not okay. So what we'll do, we'll flip each and every character from this, like from this position. And this will become 1, this will become 0, 0, 0, 1, and 0. Then these are okay. This is okay. Again, this is not okay. Like we have a 0 here and I want a 1 here. So again, I'll flip this, and now these will be back and these are now no more. This is okay. This is again now not okay. So I'll again flip this and I'll get something like this. This is okay, and this is okay. So 3 times I have flipped, right? Similarly, we can find that for what is the number of times we have to flip to get this string. But now when I'm saying that I'm flipping, while showing you I'm flipping all the characters ahead, but do we actually need that? No. We just need to know that whether we have flipped the coming string or the following string or not, because there are only two options. If we have flipped, instead of 0, 1, we'll get 1 and 0. And if we have not flipped, if this is the case, we have flipped. And if we had not flipped, then simply like the characters mean what they denote. 0, 1 is 0, 1. So this is a very simple problem. Just check for these two cases. First, try to make this, then try to make this. And when you're flipping, like if your characters don't match, increase your answer by 1. Is it clear? Yes, no? Or is anyone having any doubt in this? Okay, so let me show you the implementation. So this is the implementation. In this, I have first taken string n and n as input, like the integer n, that is the length of the string, and the string itself as input. Now this is my answer for the first scenario. This is my answer for the second scenario. For flipping, I have taken this f. So what I have done when I'm checking for the first time, I'm checking what is this? Like this is the character. If f is 0, this will give me 0 character. If f is 1, this will give me the first character. So this is one way. I'm iterating through the characters of string s, and I'm checking like this. If the character that I want is like is actually present in the string at this position, then for the next time I want this character. I'm just flipping. Like if it was 0, I want 1. If if it was 1, I want 0. So F denotes what character I want. So this is, by the way, is XOR. Like if you take 0 XOR 1, you'll get 1. And if you do 1 XOR 1, you'll get 0. So basically, if you take XOR of either of 0 or 1, you get the opposite. So if this is not true, that this is not the character that I want, then I'm increasing my A. And for the next time, I'm not flipping. Why? Because if currently I wanted 1, in the next place, I also want 1. Why? Because I've already flipped. Like at current position, I wanted 1. And technically on the next position, I want 0. But since I have flipped, I'm looking for again for 1. So that is this. Like there are many ways to do this. This is just one way to do this. Like why? Because this is easier to write. I just wrote this much, then I copy pasted it here. So what is this condition? This is just like, this is the character. This is like if F is 0, then just checking that this is the 0th character. Otherwise, if F is 1, checking that this is the first, like digit 1. Is it making sense? Yes, no? And this is just starting from 1. Here we started from 0. Here I am starting from 1. And the same thing, like these two are the same thing. Finally, I can print minimum of A and B. Any doubts? This if condition is simply that, like this is the character, right? I'm iterating through over this string S. So if F is 0, this is the 0th character, like this complete thing is 0th character. Otherwise, it is character 1, like this thing. This thing. Okay, now it's gone. By the way, is any doubts? Yes, no? XOR part is if you have 0 and you take XOR with 1, you get 1. If you have 1, you take XOR with 1, you get 0. So this is what I'm doing. For 0, you'll get 1. For 1, you'll get 0. You don't have to do this. You can write something like this also. This is also the same. For 1, when F is 1, you'll get 0 this side. If F is 0, you'll get 1 this side. You can either do this or this. There are many ways to do this. Classical way to do this is just check if F, then like if F is equals to 1, then make F as 0. Otherwise, else make F 1. So in place of this, either you can do this, take XOR, or just write this condition. Is it clear? But by the way, is like this is just some alternatives to writing code. Like this doesn't mean like if you're not doing like this thing in your code, doesn't mean like this is just simply taking XOR, like if A is binary 0 or 1 and you're flipping it. If you're not doing these things, doesn't mean that like you don't have the knowledge to solve this particular problem. And this is like I don't use this many times. Why? Because I like personally try to use these bitwise operations because these are much faster than these arithmetic operations. Like this is a complete separate discussion, but yes, when I have option, I go with these like bitwise operations.
Hello, can you explain your if condition in the code,
Like
please?
which this thing.
Yeah, this thing only.
This
Yeah.
is just like the 0th character, like whether this is 0th character or like we could have done like just check whether if F is equals to 1 and this is this. Otherwise, or this character is 0. If F is equals to, like we don't have to write this again, but we can like this is what I have done. is equals to E. Now, does this make sense? Like basically, if F is 1, then you need the digit 1, character 1, otherwise you need character 0. Is it making sense?
Yeah.
Okay. Any other doubts? Okay. So let's go to the next problem. Like if you have any doubts, you can ask me. Like don't wait for others to ask your doubt, and don't be shy. And it's possible that like if you are writing like big messages, it's possible that I might skip in the chat, so you can like feel free to unmute yourself and ask me.
Can we just count s of I is equals to s of I minus 1?
And like if you're just starting from like
1.
I think you can, because if you're flipping
Come on.
like no
Yeah.
like saying just like did you try this? You are saying just like
Yeah, it worked fine.
yes,
Accepted.
you can do this also. Why? Because once you flip everything after this,
After that, all
it
digits
doesn't
will be
matter.
full.
Yes,
Yeah.
that can also be done. Like if you just like flip this part, all of the characters in this part are getting flipped. So you just
Yes.
need to count how many places are different. Yes, this can also be done. I actually didn't think about the problem. I read the problem and just implemented it. So anyway, yes, that like this can also be done. Like you just iterate through the string. If there are two different characters, increment your count by 1. Why? Because anything after this will be like all the characters will be getting flipped. So next. So in this problem, we are given that we have an array A of length n, and we can like perform the following operations on it. So we choose index I between 1 and n, like it cannot be 1 or n. And AI shouldn't be smaller than either of its neighbors. Like it should be more than or equals to its previous and its next neighbor. Then we can decrease AI by 1. Now the problem is that is it possible to make all the elements of A equal by performing this operation several number of times? So this problem is like a very basic, I would say, like it's not a constructive, it's just observation, like whether you are able to observe. See, can you ever decrease this? Can you ever decrease these two values? No, right? Why? Because for decreasing this, your I has to be this, and your I cannot be either this or this. So your I needs to be between 1 and n. And can you decrease, let's say, any of these? Like, can you decrease this? Yes, you can, as long as it's more than this and this. So as long as this is like, let's say you have you have 5 here, 7 here, and 2 here. So if this is the case, since you cannot decrease these and you cannot increase anything in between, the answer is no. So your minimum should be these two, like whatever your minimum is. Like if your minimum is 7, like in the array, it should be present at the first and the last position. And if this condition is satisfied, no matter what the values are here, like it can be like the graph can be something like, if I plot, the graph can be something like this. Like this is 7, right? And like there are same values here. Like let's say if I plotted, I got these. So as long as this is the minimum, like the first and the last values are the minimum among the array, you can always decrease. How? First bring this down, then like you'll have these two same, like you'll have something like this. then you can decrease this, then decrease this, these three one by one. Like it's always possible to decrease values in between, but you cannot decrease the first and the last value, right? So you just need to make sure that they are the minimum values that are occurring in the array. Is it making sense? Yes, no? And this is the solution for it. Like you just need to check that those are minimum. Like if either of these is more than minimum, just find the minimum and check whether this is more than minimum or this is more than minimum. If they are, print no, otherwise print yes. Is it clear? Okay. What about others? Okay, so let me show you the implementation. So this is the implementation. I have taken the minimum of the array and I have checked if the first element of the array is more than the minimum or the last element is more than the minimum. Our answer is no, otherwise it's yes. Any doubt in the implementation? Okay, so let's go to the third problem. So this is the third problem, and in this problem we're given that a binary string S is said to be good if there exists some k binary strings p1 to pk such that S is a combination of these k binary strings and each pi has even length. Now each pi contains only a single distinct character. So this means that S is a combination, string S is a combination of some even length substrings. All of these are even length and all of them have the same character. Right? So now, first of all, this part is clear, like how is S being formed, right? Like each of these is even and like each of these is having even length, each of the substrings, and each of these substrings have only one character, like either they have one or they have zero. Now, what we have to do, we are given some strings 0, 0, 1, 1, 1, 1, 1. We are given some string and we need to convert this into this kind of string. But the only thing is we can only select, we can do only one operation, and that operation is we can choose some subsequence and flip all the characters in that subsequence, like all the characters that are present in those positions. So choose some subsequence of positions. Let's say I choose, like in this, the answer, one valid answer is that I choose, let's say, this position, and then I choose like 1, 2, 3, 4. I think the string that I have chosen is of odd length. Like the string that you're given in problem is of even length. Then I choose this. So if I flip these two, I'll get 0 here, like 0 here, and 1 here. Now you can see that I can divide this string into even length, which are having same. And there is one more constraint that the subsequence that you're selecting should have alternating characters. Like I chose, like here it was 0, here it was 1, and here it was 0, right? So it was alternating. You cannot select a subsequence like this. Like you cannot select a subsequence like this because at these two places the character is same, at these two places the character is same. So you need to select places or positions which are having alternative characters. So if the last position that you selected had 0, the next position can have 1. So this is the problem, and we need to find whether it's possible, and if it's possible, like what is the positions that we're selecting in the subsequence that need to flip. Subsequence is different than subarray. All right. Subarray needs to be continuous. Subsequence doesn't need to be continuous. So first of all, is the problem statement clear? Like what is given and what we have to do? Yes, no. What about others? Okay. So now to like this is also an observation in this problem that if the string that is desired, if the string is of this or like fashion, that each substring like it's being formed from substrings of even length, and it has only one character. Like this is the property of substrings which form this string S, right? So what we can do, we can further break the string S into two characters, and these two characters will be same. We can always like, because why? Because string S was being formed by a even length substring which had same, right? So we can break two like in string S into two characters, and those characters will be same. So now we just like we are given a string S, we are given something like 0 1 0 1 1 1 1 0 1 0 1 1. So we are given something like this, and what we can do, we can form two characters bucket. Let's say this, and now we just like if there's a 0 1, we need to flip one of these. So let's say I decide that I'll flip this position. Now next, again, the characters are different. I again have to flip. I cannot flip the 0 because the last position was at which I'm flipping is the 0. So I'll flip this. This is okay because both are same. This is not okay because both are different. So I'll again have to flip 1. But now I'll flip 0. Why? Because here I was flipping 0. Here I was flipping 1. Here I'm flipping 0 again. Again different. So I have to flip 1. And I'll flip this 1. So my final string will be, I have flipped 0, I'll get 1. 1, I have flipped 1 here, I'll get 0 0. I didn't flip anything. In 1 0, I flipped the 0, so I got 1 1. In this 1 0, I flipped this 1, so I got 0 0, finally 1 1. So these are my substrings of even length that have the same character, and that forms string S. So is it making sense how I can always perform this action once to get the string S? It's always possible. Like just break your string into two characters, and if they are same, don't do anything. If they are different, just see whether if you're like previously flipping a zeroth character, so in like flip the character 1 here, otherwise flip the 0th one. Is it making sense? And this is always possible for even length, of course. Anyone having any doubts? Okay, so let me show you the implementation. So this is the implementation. In this, I have taken string n and s as input. Then this is my answer vector, final answer vector. Then I'm iterating from 0, and I'm incrementing by 2 because I have to check two characters once. Like I'm checking si and si plus 1. So that's why next time I'll go to I plus 2, not I plus 1. So I'm checking the two characters. If they are same, then nothing happens. Like this is the if block, right? If they are same, nothing happens. But if they are not same, I'm checking whether if currently my answer size is 0. Otherwise, if my answer size is something like I'm flipping something, then I'm checking what was the last place, like what was the last character which I was flipping. If it was I plus 1, like if it is same as I plus 1 character, then I'm in my answer inserting this ith position. Otherwise, I'm inserting this I plus 1. I have to like change one of these, right? So I'm checking based on this. Finally, I'm printing my answer size and character positions. I'm printing them like the positions plus 1. Why? Because while inserting this, I'm started from 0. Like this is where starting from 0. So any doubts? Okay, so let's go to the next problem. So in this problem, we're given that Elise and Bob have an array A of length n and will play a game on it. They alternate turns with Elise going first, and on each turn, let M denote the current length of array A. If M is 1, that is, there is just one element left in the array A, then the game stops. Otherwise, the current player must make a move. And for Elise, she must choose an integer, like two integers L and R. They cannot be same. And then she deletes the subarray from L to R and inserts this in their place. Like that is the absolute value of sum of the subarray from L to R in their place. And in Bob's turn, he again chooses some L and R. Again, L and R cannot be same. Then delete the subarray from L to R, and in place of that, insert the complete sum of their in their place. Now, this is okay. Like they both are selecting some subarray, and the subarray size should be more than 1. Now, Elise wants to maximize the value, and Bob wants to minimize it. Like there would be finally one element left in the array, right? So Elise wants to maximize it, and Bob wants to minimize it. If both Bob and Elise make their moves optimally, what should be the final answer? So this is also a straightforward observation problem. See, first, let me explain. There is an array A. In Elise's move, she needs to select some L and R. Now, note that L and R cannot be both same. So they both, for Elise and Bob, they cannot select a subarray of size 1. So they need to select a subarray of size more than 1. And Elise will take some of this, like delete this subarray, and in place of this, insert this element. Otherwise, Bob, like in Bob's move, again, some subarray needs to be selected. Again, subarray size cannot be 1. And Bob will remove this subarray, and in place of it, just insert this element sum. Now, Elise's, like finally, there will be just one element left in the subarray. Elise wants to maximize this, and Bob wants to minimize this. Is the problem statement clear? Now let's look at Elise's. Like, can Elise ever decrease the sum of the total array? Can Elise ever, like, by after her move, can the sum of total array decrease? The total sum of the array, if she is taking modulo? No, right? And can Bob ever change anything? Like if Bob is doing a move, can he change the sum? Like the sum of the array? No, right? Bob can never change the sum of the array because he'll just replace 5 elements with their sum. So Bob can never change the total sum of the array, and Elise can only increase it, not decrease it. So technically, see, let's say Elise is having the first move. Elise can only increase, and Bob can have no change. Now Bob wants to minimize it. So forget about minimizing. He cannot do anything. He cannot minimize anything. He'll try to avoid Elise from increasing it. Now Elise has one move. Bob has, like, Elise is starting. So Elise will do one move, and then it's optimal. Like it's optimal for Bob to choose the complete array. Why? Just because he cannot decrease the sum. Elise cannot decrease the sum, so nobody can decrease the sum. So if nobody is able to decrease the sum, he just should choose the complete array and just make a one element of it, because you cannot minimize this. Elise can maximize it if she gets her turn, but what should Bob do? Bob should, in his move, he should just take the complete thing and make one element out of it. So now Elise has one turn, and Bob has 110. Why? Because in Eliza's turn, she will first try to increase as much as she can. And then in the next turn, Bob will just take the complete array. So there are just two moves. Bob's move is pretty much like we know what it will be, right? But for Elise, now we need to see what her move will be. Now she has an array, and whatever array she chooses, if it is having positive sum, nothing will change. Like if sum was 5, she just replaced it with like this thing. But if sum was negative, if let's say sum like the subarray that she chooses -5, she'll replace it with +5. Why? Because she'll take this thing, right? So Elise will try to find the like the subarray which is having minimum sum, minimum negative, or you can say as like negative sum. She'll try to find the subarray which is having as negative as possible sum. So in your like what we have to solve, we just need to find the subarray which is having maximum negative sum, and our answer will be final. Like what should be the answer? Answer will be total sum. And earlier we were getting like minus maximum sum. Let's call this as answer. Now we are getting like earlier we were getting this like negative, right? Now we won't be getting it because we are getting it in positive. So what is the difference between these two? It is 2s, right? So we just need to add 2 times answer. So what we have to do, we just need to find the subarray, like the maximum negative sum subarray. Is it making sense? Yes, no? Okay, now there is just one thing, like we already have, like all of us would have solved a problem like maximum sum subarray. So how is this problem different than it? First of all, we are actually looking for minimum sum, not maximum sum. The second thing is we cannot have subarrays of size 1. Only these two. Subarray length needs to be more than 1. So we can apply some advanced cadence, or we can just like use prefix sum. And when you're at this place, just find what is the maximum sum. If you have to find sum of subarray, what will you do? Let's say you need prefix sum up till here, you have prefix sum up till here. You have these values, prefix sum, let's say B, prefix sum A. If you subtract prefix sum B minus prefix sum A, what will you get? You'll get sum of this part, right? So we can also do this, that if you are at ith place, just find what is the maximum sum in this part, maximum prefix sum in this part, and at every position try to take like prefix sum at I minus the maximum sum up till this part. So let me show you the implementation. So this is the implementation. What I have done, I have taken array A, I have taken n length of array as input, then I have taken array A as input. Initially my maximum sum is minus 10 to the power 18. Then this is my prefix sum and this is my total sum, and my answer is 0. Answer is basically the maximum negative sum that I can get. Then I'm iterating through my array, I'm calculating prefix sum, and if like my I minus 2 is more than 0, why? Basically I need to check not I minus 1, because my array size cannot be like the subarray that I'm choosing, or the subarray for which I'm trying to get the maximum negative sum cannot be of size 1, because Alice and Bob cannot choose a subarray of size 1. So I'm just finding if I minus 2 is more than 0, then maximum sum can be maximum sum up till I minus 2. So I'm trying to find what the maximum sum is, and finally my answer after each step can be like the maximum negative sum that I can get is answer is minimum of answer or prefix sum up till I minus maximum sum that I can get up till I minus 2. Finally, I can print sum. Since this is negative, I am doing 2 times answer. Like note that this would be negative. Why? Because initially I've initialized it with 0 and I'm taking minimum only. So either this will be 0 or negative. So this will be more than, this complete thing will be more than or equals to sum. Let's dry run for some one test case. So let's say 4 minus 1, 5 minus 100. and 1. So prefix sum, let's try to first calculate prefix sum. 4, 3, 5, 8, minus 92, minus 91. This is right. Is this correct? Yes. So I'll start from here. Prefix sum is 4. I don't have any other places. Then let's say prefix sum here is 0. Then I'll come to 3. So 3 is the prefix sum. So 3 minus 0. 3 minus 0 is 3. So sum of this part, okay, let's have that thing also. So maximum sum, maximum prefix sum up till now, maximum sum is that thing only. So here it was 0. Here it will still be what did I initialize this with? I initialized this with 10 to the power 18, right? So I'll make it 4. What did I initialize it with? Just give me a second. In my code, I initialized it with 10, minus 10 to the power 18. So minus 10 to the power 18. Then I come here, this becomes 0. I'm here. When my I is here and I'm checking what is the sum I can get up till here, before this maximum sum. So it is 0. So 3 minus maximum sum that I can get up till I minus 2 is 3. So the if this is my endpoint, the maximum negative sum that I can get is 3. So answer is minimum of 0 initial value of answer or 3. So 0 only. Then I come to 8 and again I check up till here. So maximum sum now will be 4. So 8 minus 4, again I'm getting 4. Then my maximum sum here is 3. 4 is better. Maximum sum here is now 8. So I'll take this 8. But when I'm at here 4, when I'm here at 4, I would be checking it with this minus 92. So minus 92 and minus 4. So sum of this is minus 96. So my maximum sum here is 4 and my current sum, prefix sum is minus 92. So my answer will be minimum of 0 or minus 96. So I'll take this answer as minus 96. And after this, simply we can do here for here also minus 91 and 8. So this will be minus 91 minus 8, minus 99. Is it right? Yes. So I'll again update my answer with minus 99. So this is the maximum negative sum that I can get for any subarray of size more than 1. And my final answer would be sum of this plus 2 times minus, since I am subtracting, why I'm subtracting? Because the sum is the answer, this value, and this is the sum of this subarray basically. This is negative. So this is the answer. Is it clear? Okay, perfect. So prefix sum is basically if you have a range and you need to find sum of any range, you can use prefix sum up till, let's say, I minus prefix sum up till j. So this will give you sum of this part. So that's it for today, and thanks for joining.